students, I welcome you all on India's largest live e-learning educational platform, that is Gradeup. Before I start the session, let me apologize for my delay. It was not intentional. There was some technical issue. I was grappling with it, and my back-end team was constantly working with me throughout this. And fortunately, we have come live. So all the candidates who are waiting for me, thank you so much for waiting for me, for your patience. Now quickly tell me whether my audio and visual quality is okay for you, so that we can proceed for the session. Neeraj, Pal, Ranjit, Yashwant, Vicky, all of you. If you are there, please tell me whether my audio and visual quality is okay for you, so that we can proceed for the session. Neeraj, Pal, please tell me whether my audio and visual quality is okay for you, so that we can proceed for the session. So as you see on your screen, today we are going to discuss the induction motor part. We will be starting with the construction and working principle, everything, and then we will be going to the torque equation. So in the previous class, we were discussing about the parallel operation of the alternators, and now we are going to discuss about the induction motor. We will be starting with the construction, working principle, and then we will be coming to the torque equation of the induction motor. Okay. Now the first slide on your screen shows a brief introduction about myself. Some of you may be joining me for the first time. So my name is Ashutosh Saxena. I have 10 plus years of teaching experience. I completed my M.Tech from IIT B.H.U in 2010. I have written a couple of books also on engineering, ethics and power system. My areas of expertise are power system, electrical machines, electromagnetic field theory, material science and engineering ethics. The next slide shows an information regarding the Target Gate 2021 course, that is batch 2. With the overwhelming response of the student for batch 1, we have launched batch 2. And the most distinguishing feature about this batch is that it is going to be a bilingual batch, so that Hindi and English दोनों में बातचीत होगी and language is no more a barrier for your learning. Rakesh Tavreja sir, myself, Ashutosh Saxena, M.N. Ramesh sir, Vijay Bansal sir, Chandan Jha sir, very eminent experienced faculties are going to take classes in this, and let me tell you, more than 11,000 students have started the free trial. So if you want to experience how Gradeup is changing the life of thousands of students, you at least go and start the free trial on the Gradeup app. Is it clear? Now let us have some of the features of this Target Gate 2021 second batch. There is going to be 550 hours of live classes, 5,000 plus practice questions, study notes, full length mock tests, daily tests, subject wise tests, and the regular classes have started from 12th of May. If you have any query regarding this, then you can contact this number. You can write your queries to this email ID, or you can directly contact our backend team member Anand Pandey on this email ID. Is it clear? Now when everybody is staying in their home, when everybody is secluded, restricted in their home, the Gradeup is reaching out to its students. At the comfort of their home, the Gradeup is coming to you with the Gradeup classroom free of cost classes. Engineering Services 2020 means practice classes are running 9 AM in the morning. I am taking power system concept on fingertips classes 12 PM. And Vijay Bansal sir is taking concept on fingertips classes for power electronics at 2 PM. Is it clear? Good evening, Goda Kavya. So now let us start with the session. And today we are supposed to start with the induction machine. Is it clear? All of you, please tell me yes or no in the comment section. Are you ready? Should we start the class? Should we start the class? See, and let me tell you one very important thing. See, we are putting lot of efforts to make these sessions for you. So I want 3 commitments from all of you. Number 1, you have to like this video, share this video, and you have to subscribe to this channel if you have not subscribed, and hit the bell icon. That is very, very important, so that you get updated for all the informations. You don't miss any of the lectures. So please tell me, should we start the class? Is it okay? Now, we are going to talk about the induction machine. The first statement that you should understand about the induction machine is that it is a singly excited machine. It is a singly excited machine. First difference with comparison to DC machines, commutator machines, or the synchronous machines, you can say. DC machines and synchronous machines, we have talked about this, they are doubly excited machines, whereas induction machine is a singly excited machine. Second important point, it works on the principle of induction. What is the principle of operation of induction machine? Induction principle. That is why it is called as induction machine, induction motor or generator. Third important point, it is like a rotating transformer whose secondary winding is always short circuited. I hope you are getting this information. Third point is very, very important. Your induction machine is like a rotating transformer. In the transformer, you are having primary winding, secondary winding. In the induction machine, you are having stator winding, rotor winding. But one very, very important difference is that in case of transformer, we say that the secondary should not be short circuited. But in case of induction machine, the secondary is always short circuited, whether it is a squirrel cage induction motor or whether it is a wound rotor or slip ring induction motor. The rotor windings are always short circuited. This is the point. Is it clear to all of you? I hope it is clear to all of you. Now see, like any machine, your induction machine is also going to have two important parts. Number one, stator, and number two, rotor. If you see, stator is nothing but the stationary part. Good evening, Bhargav. And rotor is the rotating part. Simple as that. Now what we are going to do, that we will understand when we discuss the working principle of induction machine, but this much you should understand, that you are going to provide, because we are talking about motor. Whenever you are talking about induction machine, the 95% of your discussion is going to be on induction motor. Okay. We are not that much interested in induction generator, and the reason you may be knowing, let me give you what is the reason. The reason is, induction generator can generate only real power. It requires reactive power support externally. What is the meaning of this? The meaning of this is, whether it is working as a motor or generator, it is always going to consume the reactive power, and this is happening because the very idea or the very principle of induction machine is the induction principle. Induction principle is, it is dominantly acting as a absorbing or the sink of reactive power. So even if it is working as an induction generator, it requires reactive power support externally. That is why most of our discussion is going to be focused on induction motor. Is it clear to all of you? Please tell me yes or no in the comment section. Is it clear to all of you? Please tell me quickly. All the candidates who are live with me, please tell me quickly yes or no in the comment section. Is it okay? Okay, now see, if you see the stator, very simple. See, I have already last 2 hours I was working on this slide and I have prepared some notes and diagrams so that we can easily go through the sessions and we can save our time. But see, it is you never know what is going to happen. For last 2 hours I was working on these slides, but at the last instant it got stuck because of some technical issue. But anyways, we have to keep moving. That is the basic idea of life. How much obstacles you get in your life, you have to keep moving. Okay, if you cannot fly, then you have to run. If you cannot run, then you have to walk. And if you cannot walk, then you have to creep. But you should always try to go ahead. You should always try to move, never stop. That is the idea. Anyways, philosophy is over. Coming back to the point. Stator, we are saying it is going to have, your stator is going to have inner periphery made of slots at the inner periphery made of silicon steel laminations. That is not that much important. Some of you may be knowing, some of you may not be knowing. Now this stator is going to contain, stator slots are going to contain 3-phase windings that may be connected as star or delta as per the starting methods. I hope it is clear. Now let us talk something about this stator winding that is very, very important. If you see, for induction motors, for stator winding, we are defining the phase group. What is phase group? These are important terms. If you want, then you can take the photograph also. You can take the snapshot so that you can remember it, you can relate it very easily. Phase group we are defining as the number of adjacent slots or conductors belonging to the same phase. Simple definition. All the adjacent slots belonging to the same phase we are defining as phase group. Now what is phase spread? This we have discussed in our previous class when we were discussing basic principles of rotating machine, different lectures we had. So phase spread we are basically defining by M beta. You know what is M? M is going to be number of slots per pole per phase, and what is beta? Beta is the slot angle. So if one slot angle is beta and total number of slots per pole per phase is M, then what is the total phase spread? The phase spread is going to be M beta, that we have discussed when we were discussing the synchronous machine details. Now this phase spread in case of induction machine stator windings, generally we are having 2 types of configurations. Number 1 we are calling as 120 degree phase spread, and number 2 we are calling as 60 degree phase spread. We will read about some details about them, but before that let us see how it looks like the 120 degree phase spread and 60 degree phase spread. Now first we are going to discuss about the 120 degree phase spread. In this 120 degree phase spread, we are defining the phase spread as 120, where this M is nothing but the number of slots per pole per phase. This beta is the slot angle, which is defined as 180 degree divided by slots per pole per phase. So all these formulas, I hope that you must be aware with this. S is the number of slots and P is the number of poles. I hope it is clear. Now I am going to take a case so that I make you understand how it is going to be. Suppose you are having number of slots as 12. Suppose you are having number of slots as 12. Okay, is it clear? You are having number of slots as 12 and suppose number of poles you are having as 2. So can you tell me what is going to be your beta? What is going to be your beta? It is going to be 180 degree divided by number of slots per pole. So it is going to be S by P. So it is going to be 180 degree and number of slots per pole is going to be 6. So your slot angle is going to be 30 degree. Is it clear to all of you? Is it clear to all of you? I hope you are getting this. Now if you are taking this case of 12 slots, so I have taken 12 slots 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now when you are having 120 degree phase spread, what is going to happen? Let us try to find the number of slots per pole per phase, because you are saying M beta as 120 degree. 120 degree is the phase spread, and beta you have just found. For this case we are taking one example. Yes, Sunny, you are right. This we are taking as slots is equal to number of slots is 12. So what is going to be M? M is going to be 120 degree divided by 30 degree. So number of slots per pole per phase is going to be how much? It is going to be 4. I hope it is clear. So this is the winding connections. This is the winding connections for 120 degree phase spread. Now what is going to happen? Listen to me properly. We are going to connect. This is first slot conductor, second slot conductor, third slot conductor, fourth slot conductor. So what is actually happening? If you want to know the phase voltage between A1 and A2 terminals, then it is going to be the phasor addition of E1, E2, E3, E4. Yes or no? If you want to write EA, then this EA is going to be E1 plus E2 plus E3 plus E4. Now these E1, E2, E3, E4 for the corresponding conductors, they are not in phase because they are in adjacent slots where the slot angle is 30 degree. It means all these E1, E2, E3, E4 are going to be having a phase difference of 30 degree. Just see here. This is the actual phase difference between E1, E2, E3, E4. So E1 is if vertical, then E2 is going to be 30 degree slot angle, where E3 is again 30 degree slot angle, E4 is again 30 degree slot angle. And if you have a phasor sum of E1, E2, E3, E4, then it is going to give you A phasor. Similarly, if you are going for B phasor, then you can see from here, you can observe from here E5, E6, E7, E8. You add them up and you are going to get B phase. Yes, Sunny, you are right. Similarly for C phase. So this is how you are getting a 3-phase distributed winding for the stator. This is for 120 degree spread. Now let us try to see the 60 degree phase spread. Now if you are having a 60 degree phase spread, and let me take the same example I am taking. Suppose you are having number of slots as 12, number of poles as 2, and you are taking M beta is equal to 60 degree, where you have found beta is equal to 180 degree upon 12 divided by 2. So this is going to be 30 degree. So from here, if you want to find M, then you will get M is equal to 60 upon 30, or getting M is equal to 2. Is it clear? Now if you are having number of slots, per pole per phase is equal to 2. Yes or no? Now what is number of slots? Number of slots are 12, number of poles are 2. I hope it is clear. So number of phases are going to be how much? From here you can calculate if you want. So it is going to be 3. Is it clear? Ranjit Mahal beta, what is your doubt? Please tell me. What is your doubt? You tell me. Now see what is going to happen. Suppose the total peripheral angle is going to be 360 degree. Okay, 360 degree, and if you are going to have 60-degree phase spread, so what is happening? You are getting 6. It means what? The conductor in the first slot has to be connected to the conductor to the, you have to go 6 steps forward. So you have to connect one with conductor number 7. One you are going to connect with conductor number 7. Okay. Similarly, you can see the different parts of the windings, but again you have to understand that suppose if you are trying to find A1 from this, then the potential between A1 and A2, that is A phase voltage, it is going to be E1, E7. Now E1 and E7, they are going to be in phase. E1 and E7, they are going to be in phase. Are you getting? They will be added, simply added. It is going to be a repetition. And if you see this E2 is going to be having a slot angle 30 degree like this, something like this. If you see this diagram, this is going to be E1, this is going to be E1, this is going to be E7, this is going to be E2, and this is going to be E8. Okay? No, it's not Ranjit Mahal, no problem beta with that. If you have any query, then you can ask me. Now if you go for the B phase, you can see from the windings later on, we are having very less time, so we have to little run, otherwise it will not be possible for me to complete the topics we have mentioned for today, because after today we will not be having a class, so we will be meeting after some time. So you can take the winding details and you can understand it, not that big deal. So it is going to be E9, E9 and E3, and this is going to be E10, and this is going to be E4. Okay, all these are going to have 120 degree phase displacement. That is the overall idea. Now I want to draw your attention. No, when you are saying M, listen, when you are saying M, then M is going to be number of slots per pole per phase. It is not pole pair, it is per pole. If you are asking for 120 degree phase spread, listen to me, it is very easy. If you know 120 distributed winding, what is happening? Distributed winding, it is going to be something like this. Now if this much is for phase A in terms of slots, so it is going to be slots per phase, and this is going to be how much? This angle is going to be how much? If M is the number of slots per pole per phase, see why we are saying per pole per phase? Because for one pole, if it is a forward conductor, then for the next pole, it is going to be the return conductor. The current must be in a loop. That is why we are saying per pole per phase per pole. So this angle is going to be M beta, because this individual angle is going to be beta. So this M beta we are defining as phase spread. Yashwant Sani, I hope that it suffices your query. Okay. Now if you compare the distribution factor we have seen sine M beta by 2 upon M sine beta by 2. So this we have discussed in our previous class. If you are having a uniformly distributed winding means beta is going to be very small. So if beta is very small, then you can assume that sine beta by 2 is approximately equal to beta by 2. So you can write Kd is equal to sine m beta by 2 upon m beta by 2. Now this m beta is nothing but the phase spread. This is nothing but the phase spread. So if you want to write it for 120 degrees, so you can write it like sine 120 upon 2 divided by 120 upon 2, and if you want to write it for 60 degree phase spread, so you can write it sine 60 divided by 2 upon 60 divided by 2. So now you can compare the induced EMF with respect to the two different phase spread. So you can find it that the distribution factor for the 60 degree phase spread is going to be 1.15 kT 120 degree phase spread. It can be asked in your GATE or engineering services examination, so you can understand it. Is it clear? Yashwant, Sunny, all of you, please tell me, is it okay? Is it clear? Okay, now let us have some conclusions about that, then we are going to come to the slots. So some conclusions I want to draw here when we are discussing these. Let me use this. Let me use this space. So the first thing we are saying is that practically 60 degree phase spread is preferred. Practically 60 degree phase spread is preferred. Why? Because it gives you better voltage. You have seen the distribution factor, power ratings. If voltage is better, power rating is going to be better. But the important point about the 120 degree phase spread is that it eliminates third harmonic component. Okay, you must have read that in synchronous machine. If you want to eliminate the basic purpose of distributed windings and short pitching the coil, that is nothing but the reduction of the harmonics. And if you see for this induction machine, the 60 degree phase spread is basically used for 5th and 7th harmonic, and 120 degree phase spread is used basically to eliminate the 3rd harmonic. Now with this 120 degree phase spread, the idea is, even though this 3rd harmonic is present, in phase, it is absent in line. That is the idea. I hope it is clear to all of you. Okay. So now let us see the types of slots you are going to use for your induction machine. If you generally see, there are 3 types of slots that are generally used for different machines. So we are going to discuss about them. First one, we are having open slot. Then we are having semi-closed, open slot, closed slot, and semi-closed slot. Semi-closed slot. Is it clear? I hope it is clear. Now if you see, for the open slot, as the name indicates, Deva Santosh, beta, I can speak on economics also. Everybody can speak on economics. Everybody can speak on politics. Everybody can speak on anything. But the time must be right. You must speak when it is required. If you speak when it is not required, then even if you have done a PhD or you are the most intellectual person in that field, it is not going to take you anywhere. I hope you understand my point. You should always speak when it is required. I don't think that right now economics is required. So listen to me properly. This is the obvious thing. If your slots are going to be open, then the winding design and their maintenance is easy. Yes or no? Yes or no? How you are going to have the open slots? Your open slots are going to be something like this. Let me draw a rough diagram so that you understand what is open slot. Suppose this is your rotor periphery. This is your rotor periphery. And these are your stator slots. Is it clear? So these type of slots we are calling as open slots. Now if you come to closed slots, definitely the winding design and maintenance is difficult. Okay? Because it is a closed slot. So if you are going for closed slots, then it is going to look something like this. So your slots are going to be something like this. These are, we are calling as closed slots. These we are calling as open slots, and these we are calling as closed slots. Now we are coming to this semi-closed slots. For the semi-closed slots, the winding design and maintenance is quite difficult. The meaning is it is going to be difficult even in more in comparison to the closed slots. Because of this design of the slots, just see here how it is going to be semi-closed. So this is your rotor and this is going to be something like bell shaped. So it is very difficult to keep the windings intact because it is going to have a rotating motion. So these slots winding design is going to be, this is your semi-closed slots, you can understand. Is it clear? Now if it is an open slot, it is very logical. If it is an open slot, then the air gap is more, yes or no? Air gap is more. If air gap is more, then reluctance is high. If reluctance is high, yes or no, then leakage flux is less. Are you getting this? If reluctance is going to high, the leakage flux is going to be less. Now coming to the closed slots. In this, air gap is very small. So you are saying reluctance is low, and if reluctance is low, then definitely you can say that the leakage flux is more. Now if you come to the semi-closed slots, then the reluctance is going to be moderate. If the reluctance is going to be moderate means in between the open slot and closed slot, then the leakage flux is also going to be moderate. Is it clear or not? Are you getting this? Practically used of these but I am not that much capable to understand your English. You have to listen to me, beta. You have to listen to me. Okay? You have to listen to me, then we can discuss upon. Okay. Now if it is going to be open slot, then definitely you require more magnetizing current. This point is very important and all of you should try to understand. If air gap is more because it is open slot, so more magnetizing current is required to establish the flux. Yes or no? Establish the flux. Yashwant sir is asking, sir, how is it semi-closed, sir? See, can't you see this is semi-closed? Semi-closed means the major part is closed, a little bit opening is there. You can understand it like this. These types, something you understand. See, if you want to understand, then I can give my 100% to make you understand. But if you have drawn curtains on your mind that you will not understand whatever I do, then it is not possible for me to make you understand. This is the point. Now if you are having open slots, it is going to have more magnetizing current is required to establish flux. Okay. If you come to the closed slots, so it is going to have less magnetizing current to establish flux. If you come to the semi-closed, then it is going to be moderate. Now you please try to understand, if it is more magnetizing current, then operating power factor is low. Are you getting this? More magnetizing current means more reactive power. You remember this? Suppose if this is P and this is Q. So this is going to be your phi angle. Now if you are saying the reactive power is more and real power is less, the situation is something like this. This is P and this is Q. So this is going to be phi angle. So if phi angle is increasing, then you can say power factor is going to be reduced. If you are increasing the component of the reactive power, magnetizing current is required means more reactive power is required to establish the flux. If you come to this closed slots, then operating power factor is comparatively high, you can say, and for the semi-closed slots it is going to be moderate. So there are number of lists are there, you can understand this, but in general if we say, then there are a lot more points which you can mention, but most of the time you can say for induction machines, stator and rotor, the semi-closed slots we are going to use. We are going to use the semi-closed slots. Semi-closed slots are generally preferred because of the above said conditions, preferred for induction motor, stator and rotor. Now I want to give you one important point. If you see your induction motor, I have told you that your induction motor is nothing but a rotating transformer. If it is going to be a rotating transformer, listen to me very properly. In case of your transformer, we have said that the magnetizing component of the current or the no load current is 2 to 5% of the full load current. You remember this when we were reading the transformer, that your no load component of the current or the magnetizing component is approximately 2 to 5% of the full load current in case of transformer. But when you come to the induction machine or the induction motor, in the induction motor what is happening, it is not just induction, it is induction and rotation, and it is singly excited. It means there are two important points for induction motor construction which you must understand, that the no load component or the magnetizing component is going to be around 25 to 30 or 35% of the full load current. This is the reason, listen to me properly, this is the reason the air gap between stator and rotor periphery is kept minimum for induction machine. These are important points. Okay, Ranjit Mahal, is it clear? Now we are going to come to the rotor. I think we have discussed sufficiently for the stator. What are the different things we have to read? Now let us come to the rotor. Now the first point we have to understand for the rotor of the induction motor, that it is going to be always short circuited. It is going to be always short circuited. This is the first thing. Now why we are saying it is always short circuited, we will try to understand. But if you see generally for the rotor of the induction motor, you are having two designs. Squirrel cage induction motor, and then you are going to have slip ring, or you can say wound rotor induction motor. Is it clear? These two types of rotor constructions you are having. Now if you see your squirrel cage rotor, you can find some analogy from here in this diagram, but you listen to me, you keep watching this diagram and you listen to me, that your squirrel cage rotor, all of you must be knowing that it is nothing but like the old age conventional cage in which the squirrels were used to catch. Yashwant is asking, sir, that increment in magnetizing current is to supply the rotational losses or in general mechanical losses. Now you listen to me. If time permits, then we are going to discuss the power stage also, but you listen to me what is happening. You try to understand from my point of view. The way I am telling you, I think it is more easy to understand. I am saying that your induction motor is a rotating transformer. Now when it was transformer was a stationary device, a static device. So there was only induction principle from primary to secondary. When it comes to the induction motor, it is not just induction, it is induction and rotation. And where is the supply? Where is the energization? Excitation. The excitation is only at the stator winding. It means because of induction and rotation, both the things, you want more reactive power from the supply to establish this induction and rotation. That is why the no load component of the magnetizing current, or the magnetizing current you can say, majority of that is nothing but magnetizing current. That is 25 to 30% of the full load current. That is the reason. Now because that you can understand that your induction motor is like it is standing on only one leg, only single support it is having. Because it is a singly excited machine, so all the responsibility is on the stator side, supply. Yes or no? So if it has to maintain a stable operation, the air gap between the stator and rotor periphery must be minimum as much as possible. I hope it is clear. Now if you see, the squirrel cage is nothing but your age old, you can say there are two end rings, and there are number of slots in which there is conducting rods, you can say, and all the conducting rods are end short circuited by these end rings. In general, you can understand that it is like a cage, a squirrel cage. So this is some general idea. Now next we are going for, that is slip ring or wound rotor induction motor. Now if you have seen this wound rotor induction motor or slip ring induction motor, instead of having a squirrel cage it is not winding, it is kind of a cage. Okay, but if you come to the slip ring or wound rotor, then it is going to have windings, three-phase windings, and those three-phase windings are connected in star, not in delta. Why they are connected in star? Because at the starting time you want to include some starting resistances. What is the reason? That we will understand later on when we will discuss different things. But the point is that your slip ring or wound rotor induction motor windings are going to be connected in star to facilitate the insertion of external resistance at the time of starting. What is SC? Where is SC, beta? I am not getting your point. Where you have got SC? Where you have seen SC, beta? Okay, you are asking why short circuit? You are asking why short circuit? What is your point, Ranjit? Always, it is my humble request to you, whenever you are trying to ask your doubt, you please place your doubt in a proper manner, proper language, so that I can understand it. Your way of asking may be different, my way of understanding it may be different. If you want to write in Hindi, you can write in Hindi. If you want to use English, you can use English, but please always elaborate your doubt. He is asking why short circuit. Yes, that is the reason. I will explain, because that was supposed to be discussed when we were discussing the working principle. These rotor windings are going to be always short circuited. What is the reason? The reason is, I was supposed to elaborate this, but let me tell you. Okay, let us discuss it here, because we are supposed to discuss the working principle. So let us see what is happening in this induction machine. You are giving a three-phase supply to three-phase distributed stator winding. Yes or no? It is going to give rise to a stator rotating magnetic field. All of you must be knowing this. If you give a three-phase supply to a three-phase distributed winding, then it is going to give rise to a rotating magnetic field, because it is at the stator side, so we are calling it as stator rotating magnetic field. Now this rotating magnetic field is going to cut the, or link the, or cut the rotor windings. Now these rotor windings, if they are linking with a time varying flux or the field, then definitely there is going to be induced EMF. Now because your rotor windings are always short circuited, always short circuited, then what is going to happen? Because of this induced EMF, there is going to be rotor currents. Now these rotor currents are going to generate again, because if it is going to be current flowing in the winding, it is going to have its own magnetic field. So this rotor current is going to give rise to rotor rotating magnetic field. Now what is happening? Because of the interaction of these two rotating magnetic fields, stator and rotor, there is a torque production, because of which your induction machine is going to rotate or the start. Is it clear to all of you? I hope it is clear, Ranjit Mahal. Okay. Now, if you want to understand from here the working principle of the induction motor, you can understand. Suppose this is your stator, and suppose this is your rotor. This is your rotor, and this is your stator. The same thing that I was telling you. Now, the moment there is going to be a rotating magnetic field because of the currents in the stator winding, these flux is going to cut the rotor windings and there is going to be some induced current in the rotor conductors. The moment there is current in the rotor conductors, this current is going to have its own flux and there is going to be some distortion. So your actual flux is going to be something like this. It is going to be something like this. It is going to be something like this. Okay? There is going to be some distortion of the flux in between the air gap. Now this rotor will be inclined or tending towards to rotate so that this distortion in flux is reduced, or you can say the reluctance is reduced or minimized, and so that the rotor flux is aligned to the stator flux. That is why there is some torque production in the induction motor and the induction motor starts. Okay, so there is one candidate, Deva Santosh, is saying, sir, please discuss something about out of syllabus. See, for these out of syllabus things, we are having general sessions. Every week we are having general sessions. So definitely I will be coming up with these type of general sessions, because every time we keep on speaking and you have to listen almost like a passive listener, but it is not going to be so, because we are going to make you interact more and more with us so that you can ask your doubts, you can clear your doubts and you can enjoy your learning also. That is the idea. Is it clear? I hope it is clear. So friends, we were supposed to read some more things, but I think we are running short of time and it is better we stop now because it is more than 1 hour we are running this session. So I will be coming again to you in some another session and we are going to discuss some of the important topics related to your favorite subjects, whether it is electrical machines or any other subject. Is it clear? Ranjit Mahal is saying maximum air gap is okay. So friends, thank you so much. Now I am going to conclude the session, but before that let me tell you that today it is going to be the last session in this series. Not in series, this series is going to be going on, but just today I am going to be taking the last session, the sequence I was taking, and I will be coming again to you with some more concepts, questions, topics, and again after me I think the next faculty is going to continue the same time, and you can see the time and schedules you can see on the Gradeup app. You stay connected to the Gradeup and I will be coming again to you through this platform and we will be discussing a lot of things. And I want to thank you, all of you who are with me throughout these sessions. I think I have conducted almost 24 sessions in this. I think that you must have got some value addition for your topic, for your subjects, and you must have got some interest in this subject because of my efforts. I hope so. So thank you so much for all of you. Thank you so much for your time. I wish you all the best, and don't forget to stay connected to Gradeup for more and more good sessions. Now this slide tells you there are 60 plus Gradeup students in the top 100 in GATE 2020 examination, and I have already told you that if you want your photograph to be in this panel, then you have to do two things. Number one is hard work, and you all know what is number two. Number two is again hard work. Now, one important point I want to tell to all the candidates, that if you see all my playlist, electrical machines, and it is power system is also available, and you please stay tuned, stay connected to Gradeup. We are coming with lot more sessions, lot more interesting sessions. But if you have any technical doubt, if you have any query, then don't forget to contact me or the Gradeup backend team member. We are definitely going to help you in all possible respect. इट्स ओके, एसएससी सर जेई का क्विज और किया करिए, ठीक है, डेफिनेटली आई विल बी डूइंग. अक्षय माली सेइंग सर व्हाई सीएस रिवर्स. ओह, सी डोंट थिंक अबाउट सैलरी. Salary is a very small thing. You can earn money in different ways, but respect, earning respect is very, very big task. It requires lot of patience, lot of hard work. Money can be earned by anyone through any methods. You can see a lot of examples are there. But if you want to earn respect, then you have to really do hard work. Is it clear? So friends, thank you so much. Now 3 commitments I want from all of you. Number 1, you are going to like this page, share this video, all the playlists if you want, you can share in your friends, colleagues, social media platforms. And number 3, if you have not subscribed to the Gradeup channel, you have to subscribe the channel, you have to hit the bell icon so that you don't miss any of my videos or your favorite faculty videos. Thank you so much. Good night. Take care. Stay safe. Stay in your home. Follow the government regulations. And don't forget to join me again on the Gradeup platform for all the more new learning. Thank you so much. Prep smart, score better. Go Gradeup. Thank you so much.